Okay, so let's have a look what we're looking at today. So today we're looking at linear modeling. One of our goals today is to be able to create and interpret linear models. And the other important goal today is to be able to extract information that you can interpret and value information produced by a linear model. So we have this question here where we've got this table of data, and in the first part we're asked to graph it on the calculator. So what you want to do on your calculator is you want to press Control, Add Page, and add a list or spreadsheet. And then we can put some names in here. So our first one is time, and our second one is temperature. Typically, we will type these ones in, and then we'll put the information. We got 4, 6, 8, 10. And then for the information, we got 130, 209.8, 290.3, 369.2. So once we've typed it in, it asks us to plot it on our calculator. So the easiest way to make a quick plot is to press Control, Add Page, then choose number 5, Add Data or Statistics. And then we click on the bottom and we choose which one is going to be our x-axis. That was going to be time. Time is always the x-axis. And then temperature. And we see a quick plot. When we look at this plot, we can see everything is going up in a straight line. We can see this is a linear relationship. So when we choose the appropriate model for this one, the first thing we're asked to do is to choose the appropriate model in B. And the appropriate model for this one would be that it is linear. It's a linear model. Why is it linear? If we look at the dots, we see we have a constant change in y for equal length input values. So for equal length input intervals, there is a constant change in output. And this is the reason for choosing a linear model. For equal length input values, there's a constant output value. So you can see that roughly here in the data as well. We're going up there by 80. We're going up here by about 80. And we're going up here by about 80. Give or take. You can see it there in the data. We're going up roughly by 80 each time. And we can see that here the input values are going up at a constant rate. So for the constant input value intervals, we have a roughly constant rate of change in the output values. What's a reasonable domain and range for this model? What's a reasonable domain and range for this model? Well, can time be negative? No, we can't have negative time. What would time equal to 0 mean in this context? What would time equal to 0 mean in this context? That's when the experiment starts. When the experiment starts. And would that have would the liquid have a temperature at that point? So that's reasonable. So it's reasonable to say that it's going to keep rising. Is it reasonable for the time to continue endlessly? Why not? It's an experiment. The temperature is going to change. Something could happen to the gas. It can't just keep getting hotter and hotter forever. So our domain would be that T is greater than 0, maybe less than or equal to 10. We don't know what's coming after that one. So T is going to be from 0 to 10. And what about the range? Our range Well, we don't know what the range is going to be. So maybe for our model, we can't be using 0 here at this point. We've only got information here from what happens between 4 and 10. So if we only have information for what happens between 4 and 10, we can only say that the y values, which are the temperature, are between 130 and 369.2. So if you have a question like this one, it's best to take the domain and range from the table, because that's all the information that we have. So if we move into D, finding the equation for the model. So on our graphing calculator, there's two ways to do this. You can have a quick look on the scatter plot by pressing menu, analyze, and then regression, and add a linear model, and it will add a linear model in there for us. We can see that. But the best is to move over to your calculator page and press menu, statistics, stat calcs, and linear regression. So menu 613. We choose our different values. So we want time to be our x value, and we want temperature to be our y value. Note where it's going to save the regression equation. It's going to save it in F1. We'll use that later. We press OK, and we get our model here. So whichever technique you use, you're going to come to the linear model that temperature is equal to, and we get 39.9 T minus 29.5. So this is our model. Plot it on the graph. So I've plotted it on the graph here like this, and we can see how it looks. It goes through the points quite easily and clearly. So on to E, comment on your model. Okay, so is this a suitable model? Is this a suitable model? Well, notice here the R value. The R value is very close to 1. It's a very close fit to the... so the R value here is close to 1, which means it's a very suitable model. When we look at the diagram here of the graph, we can see that the line appears to go through all the points. So this does seem like a suitable model for this data. So I would say that the line passes through all the points. Okay, F, we're going to use the model to make some estimations now. So I'm just going to scroll up here to the top a little bit. We're going to use the model to make estimations, and I'll show you how to do that on the calculator. Firstly, we need to put in when the minutes are 4.5. So we've got 4.5 minutes. So here we need to find T of 4.5. So we put that into the calculator. If you press the variable button here above the 9, so if you look above the 9, you see the variables button. Click on that button, and then from all that list, look for F1. Remember, we stored the equation in F1, so we'll choose F1. Type in 4.5, and we get our answer. So at 4.5, it's going to be 150 degrees centigrade. Are we asked to just calculate? Yes, for now. So in part 2, we're asked to find what was the value? T of 20. So now we're asked to find T of 20. So again, on the calculator, press the variable button, choose F1, type in 20, and we get the answer. Ooh, let me round this one up. Let me get the calculator to do it for you. Document 7, no, missed. Document 7, what am I getting wrong? Document 7.2. I want to go to float 3. Press enter. So this is 769 degrees centigrade. Okay, our last one, A, B, C, D, E, F, G. G asks us to comment on the predictions made in part F. So are these predictions safe? Is it sensible to make these predictions? what we do is 4.5 in the domain of the function? What was the domain? So when we're commenting on the predictions, look here. So our domain is from 4 to 10, because that's all we have the data for. So because 4.5 is sort of in that range, then it is sensible to make this prediction. So we can say here, also looking on the calculator, we have the R value of 0.999, which basically is an R value of 1. So R is approximately equal to 1, and T equal to 4.5 lies in the domain. So 150 degrees centigrade is reasonable. No. Okay, so what we see here is we can see as the values go from 4 to 4.5, then you are going to get 150 lying in the middle here. But the problem with the next one is we were asked to calculate when it's equal to 20. Now, 20 is outside of the domain. We don't know what's happening. It says that this is a liquid here. It says that it's a liquid being heated. So it could be something, if it is a liquid being heated, it could be something like an oil, and it will get hotter and hotter. But what happens to liquids at a certain temperature? They'll turn to gas. And if, depending, we don't know what the equipment being used is. If this liquid turned to a gas, it would evaporate out of the bowl. We don't know if it's been contained. There is a bit of a misconception here, or a typo, I think, because I don't think that this liquid it says there in the question that it's water. I think it's a liquid, because these temperatures are too high for it to be a liquid and water. Over 100 degrees centigrade, water turns to steam, and it would escape the experiment. So it is not sensible for us to continue heating this liquid endlessly. So the domain is given that it will heat from 4 to 10. So the domain means that, yeah, it can reach something around 400 degrees centigrade, but doesn't mean it's going to be able to reach, what did we get? 770 degrees centigrade. So what I would say is in part II that, and this is where we do the interpretations. This course is called Applications and Interpretations. And this is a very typical question for our course, because we're asked to apply our math in a contextualized question and make interpretations. So in this case, we would say that T equal to 20 lies outside the domain. And then we can make some interpretations. This is not reasonable. The liquid may turn to gas. All right, just some other interpretations. So can we make it's not asked for here in the question, but can we make any other interpretations? And here from the model, what interpretations can we make from this model? What interpretations can we make from this model? What does that model tell us? Well, with a linear function, I need a little bit of space. With a little linear function, let me zoom in here for some space. A linear function is of the form y equals mx plus c. But what does the m, x, and c mean? The m is our variable amount. So usually in a situation, you have a variable amount. And then, so this is our variable amount, and then we multiply this by x, which is our x variable. And this is our fixed amount. So in a linear model, we're going to have a fixed amount and a variable amount in our questions. So a fixed amount is something that's changing for every x. In that case, this is time and minutes, was it? Was it minutes or hours? time in minutes. So our variable amount is how much is changed. Our fixed amount is something that doesn't change. It's always the same. So in this case, when we've got this model here, the fixed amount is minus 29.5. Can anyone interpret what that means? Let me hear it, Bob. Well, we don't know what type, whether this is water. If it was, it would start off as ice. Yeah, they do sometimes, but they can't, because they also say it's liquid and it's going to 300. But you're right. What this minus 29.5 is, this is the temperature of the substance at the start of the experiment. This is what temperature the substance had at the start. That's a fixed amount. What the 39.9? This is how many degrees of heat are added per minute. So roughly, we're adding 40 degrees of heat per minute in this. So this is a variable amount. Notice the units. So at the start, it's minus 29 degrees centigrade. 39.9 is we are adding 40 degrees per minute. So even the units. So our units here on this one, this has the units degrees centigrade. This one has the units degrees centigrade. Oh, degrees centigrade. Why am I not getting this right? This one has the units of degrees centigrade per minute. It's a compound. It's a compound unit. So what you'll notice when you're looking at this bit, the variable amount and the fixed amount, this will be a compound unit. This will be a simple unit, not a compound one. For instance, a simple unit would be kilometers. A compound unit would be kilometers per hour. Okay, you get?
The first one is about change and the second one is a fixed.
Exactly. Good one. The first one is about change. The second one is a fixed amount. And the reason I'm bringing up that is because one of our IXLs today that we're doing is going to be, let me see if I can pop that one up. One of our IXLs here today is about just that. So let me see if I can open it up. Come on, Google Classroom. We're in G block. We've got 5 minutes. Classwork. Okay, so this one. Okay, so we have to make a linear model here on this one. And we're told that for her birthday, Valeria's baking cupcakes. With every egg she can find, she can bake 6 cupcakes. Write an equation that shows how the total number of cupcakes that she can bake depends on the number of eggs she can find. So, how many... Sorry, I have to use my finger for that. What's our fixed amount? So what is y? What is x? Cakes. What is x? Y is eggs. Sorry. So our fixed amount. Kai, so can we stop packing up, please? What is our fixed amount? How many cakes can we bake with no eggs? Our fixed amount is 0. What is our variable amount? How much do the number of cupcakes change for every egg we find? 6. So our model here for this one is going to be y equals 6x. Okay, we can finish there for today.